Hello. In this particular case, I thought I'd keep it real simple. We're not going to build anything per se. We're not going to add a lot of LEDs or anything. We're going to work with just the Uno, the serial output box, and all we want to do is want to watch the LED that's on the board. Now notice this is an Uno, and it might be different than the one you have. So the onboard LED in this case is down here. But ultimately, it's basically the same basic platform. I just zoomed in on this one little spot so we can see the LED. I've already got a shell of a program here. You can see I'm planning on doing 6 examples. And to go over the introduction here real quick, I have already declared my onboard LED, pin 13. You can see that I've set it to output so I can turn it on and off. And in fact, I do that in setup. I turn it on. Then I would hold it on for 1 second and then turn it off again. And then I kind of want to clear this window to make it easy to see what we're doing. So what I've done here is I've created this loop that's going to be 20 times, all right? And essentially what it's going to do is it's going to print nothing. So it's just going to print empty spaces and clear the screen. So we're always going to start down here and we'll be able to add up to it. But we'll have a nice clear screen. And the last thing, of course, it does is prints ready when it's actually ready to run. So if I actually run this right now, although you can probably be in the exact same spot, you're going to see that it's going to print ready. And I do have a plan for running example 1. And there you can see example 1 actually gets displayed. Okay? So now let's do it. Let's build. Oh, and actually I do have, look at this. Here's our first instance of using while. And what this is an infinite loop. Okay? It's another way of just tying up the machine so nothing happens. So in this particular case, while it's true, well, I don't give it anything to do. Okay? It's just while it's true, and I also give it no way to be false. So, you know, for all practical purposes, it's just stuck here, waiting for something to happen. Okay? And it'll stay there until the power goes out, the processor burns out, or something terrible happens. It's just going to keep running right there, no operations. Well, forever, infinite. Okay. So now let's do it. Let's play with the our first taste of the while loop. Now I have on the side here off screen. I have pieces of code that we're going to be kind of playing with. And the first thing I'm going to do is create a counter so we can actually watch it. So created a counter. I'm going to set it equal to 0. And now let's go ahead and sort of build the basic frame. Okay, so every while loop is going to be much like everything else you've been playing with. Okay, so here's your basic structure. You're going to have whatever it is you want happening while whatever condition is currently going on, all right, within this space. And in here is where we put the condition. Well, let's do it. Let's make while counter is less than 10. Okay, oh, that was less than, oh, for heaven's sakes, 10. Okay? And let's do this. I'm going to just copy this to make this fast. I will have this code posted so you don't have to type as fast as I'm going. So what it's going to do is it's simply going to print counter, and it's going to take the integer value and turn it into a string. And then it's going to increment counter by 1, and it's going to delay by 1 second so we can actually watch it go. Okay? And it's going to get wrapped up in here until this condition is no longer true. All right? So if it's a 2 or a 3 or a 4, the condition is true. But if it's 10, the condition is false. All right? And it's going to stay within these 2 brackets until the condition is false. So let's put some information on the outside of those brackets so that we know when it actually is done. Okay? So for as long as this is true, as long as counter is less than 10, it's stuck between here and here. As soon as this is false, okay, it's going to then jump down to here to line 46, and we're going to go ahead and see what the value was that made it false. We're going to turn the LED on, and we're going to say that the loop is completed. And it won't go back again because ultimately it's going to come back up to loop, but we're going to get this infinite loop, so we're not going to see anything else happen. So let's run it. and the 1 second delay, and now we can watch counter going up slowly but surely, stuck inside these two braces. And as soon as the condition actually is no longer true, okay, which is when it incremented to the value of 10, so this went up to the value of 10, came up, oh, this is no longer true, so it jumps down here to line 46. It then in fact printed that that was not true. It turned on the LED, and it said that the loop is completed. Okay, so let's move on to another example. Let me pause it briefly. I'm going to make this faster. Okay, hold on. Okay, so you can see that I've commented out 1. We're going to run example 2. And example 2 is not that much different than example 1. I just want to point out that we can deal with things other than integers, and we can do things that are not just increments by 1. So just to be clear about it. So in this case, I've still have the same counter, but I've made it a float. Okay, so we can handle these decimal places. And I've set it at 1.2, all right, to initialize it. And then my condition that I'm going to be checking true or falseness with is going to be while it's greater than or equal to a negative 0.2. So in other words, since I have that equal to, it can actually go all the way down to negative 0.20. All right. So it's not going to be false until it gets less than that value. All right. And in this particular case, counter is going to be subtracting 0.2 every time. We still have the same 1 second delay. And then you can anticipate that it's going to be true until it goes less than this. So you can probably guess that it's not going to be false if it's subtracting 0.2 each time until it gets down to a negative 0.40. So I would anticipate a 0.40 value here. Turn on the LED, and of course we'll see that the loop is completed. So let's run this. And there we go. And you can see it's going down by 0.2, just like we've told it to do right here. It's still stuck inside the braces. We got the value here of 0.2 because we set it to greater than or equal to, and it wasn't false until it hit 0.4, in which case it dropped down to line 61. We get the display of negative 0.4, and of course we turn on the LED and we output this display. Okay, so let me pause this and set up the next one. So this one I'm going to start with the output and explain how we did it. Okay, so here's the output of this next example 3. All right, I have these two columns. I have them well labeled here, count and the double, and you can see that this one goes up by 1, and this one essentially doubles. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, on and on down till 1024. Once it gets done with the 10th iteration, okay, it ends exiting the loop. So let's see how we did it. First off, you can see that I used the switch statement and T to give me this nice uniform space. And in fact, I used it a couple of times here, you can see, to make it so that I space it out so I get the nice look to this sort of columnated table. But more importantly, I have two variables in this case. I have counter and I have I. Okay? And counter, you can see, is the one that's simply going up by 1. Okay? So we're going to have a little space printed, 1. Okay, so that would be the 1 if it's the first iteration, and then 2, and then 3. Then I actually put a period and then a tab to give me this location here. Notice, not an ln. Okay? So these two together make a single line. Okay? This first one prints this all the way to the tab, and the second one prints this to give me that nice look. All right? Now I is going to go up by 2. All right? So what's going to happen is every iteration, counter goes up by 1, but I gets a times equal 2. So in other words, I is going to get multiplied by 2 on every iteration of the loop. And it's going to do it for 10 times because I have it as less than or equal to 10. So we get all 10 displayed. And when it's done, we turn on the LED and we output the while loop completed. Okay? So hopefully that made some sense. I'm going to jump right ahead to the next example. And again, you'll have this available to you, so you'll be able to download it and look at it while this video is playing. I'll be right back. Okay, so this example is almost identical so far. The difference is, instead of multiplying by 2, I'm actually going to square it. So we're going to watch this guy go up really high, really fast, okay? But I know these Unos, and their memory is kind of shaky. They don't handle big math or big numbers very well. And you can see it's going to start giving some errors. Maybe not so much, but certainly losing clarity of thought here. And in fact, eventually it just collapses. So if I actually want to break a loop, let's say I want to stop right here. I don't want to do anything greater than 65,000. All right. Well, I can do that. I can put an if statement right inside of here. So I'm actually going to do this. Okay. And I'm going to paste it here. And the command you use is literally just break. Notice no parentheses. It's not really a function. It's just going to break the loop and force it to go right down to here. All right. So if I run this now, any value, if I gets greater than 65,000, in other words, if I gets greater than, well, this value here, it's going to break. So we're going to run this, and we're going to see that this whole chunk right here is just going to disappear. And it's going to go right down to the bottom. Okay? So we get this note here. Here's an important point. You're saying, well, wait a second, Brian. You said over 65,000, but it displayed it. Well, let's not forget that we display it before we do the if. All right? So we're going to have the value be greater than 65,000. Then we say, if it's greater than 65,000, then we go ahead and exit out. Okay? So we displayed the value before we asked whether or not it was if this condition here was true. All right? So let me set up the next one, and I'll be right back with you. Okay, so I've already got this one loading, and we're going to actually see its output, and then we'll talk about what's actually happening. So notice here, this number is not changing. It's stuck at 1, but this is going up. Okay, it's going to go up to 5. Then this one goes, and it went up 2. And this one's going to slowly climb up to 5. And then this one switches to 3, and then the process repeats. So what we've got here is a nested while loop. And you can see that happening here and here. So keep in mind that while a while loop condition is true, it's trapped in there. So while I is less than or equal to 5, it's stuck between these braces. It cannot escape that until this condition here becomes false. So we watch the outer loop, okay? The outer loop then initiates at 1, which we saw right here, okay? And then as soon as it passes this point here, it enters the inner loop. It's trapped there until this condition is false. Once this condition is then false, it jumps down here, it grabs this next line, and it increments the counter. But keep in mind, it's still trapped within this loop. Okay? We haven't made this condition false yet. So the counter went up by 1, so now it's at 2. We enter this one, we reset this value to 0. We enter the inner loop. It's stuck there counting slowly. 0, 1, 2, 3, 4, 5. Exits the loop. Increments counter. Still stuck in the loop. Goes back up. Condition's not false yet. Alright, so it resets I to 0, and it's once again stuck inside this loop. So we have a nested loop. So what we see is the outer one going up slowly, and the inner one going up in increments of 5, and then resetting, and then, of course, the process repeats until this condition is false. All right, I'm going to show you the last one, and we'll be done. Okay, so let's look at this very last example, example 6. Okay, now in this case, you can see that I'm actually using a do while. All right, now right now, when you see it going, it looks exactly like a while. So what I did is I set the counter at 1. All right, and then while it is less than or equal to 10, it went ahead and ran the stuff inside, so we saw a counter come up to 10. And as soon as this condition here is false, it exited out, and of course we get to see the light turn on, and we see the loop counted, and in fact it made it to 11, which made it false. Okay, so it makes perfect sense. Now, the odd part about a do while is that the sequencing. It's going to do before it checks. All right? In a while statement, it checks the condition before it does it. In a do while, it does it before it checks. All right? So let's make something crazy. Let's make this 100. All right? So we're going to go ahead and run this. So now it's at 100. So what you're going to see is that it's going to run, and it's going to get it up there to 101, which means that it actually, ran through this one. Counter was equal to 100, so it did this, right? And then it incremented it by 1. It waited a second, and then it checked the condition, and it said, "Oh wait, it's 101," and it exited out. All right. So this is super important. A do will run at least once. All right. While are going to check the condition before it runs. Do's run at least once before it checks the condition. And this is kind of important in robotics, because you can imagine there might be times where you want to have your robot make an important decision, or move, for example, or do something before it makes a decision. So it's a matter of prioritizing when the decision is made. Okay? So I'm going to say it one last time. Do's always run at least once before it checks if the condition is true or false. That is it, and I will see you all again soon.